Hello, Mr. Stolle here. So today we're going to look at trigonometry, grade 10, and let's get to see what we have today. So we need to look at this triangle. It's a right angle triangle. With the right angle triangle, you have put a 90 degrees here. So we have put a 90 degrees here, and the side opposite the 90 degrees is what we call hypotenuse, and this hypotenuse is the longest side. Okay, so it's the longest side of all. That's what you must know. So the longest side. And now when we look with respective to this theta, this angle here, we are saying this side here, it is adjacent. So here we can call it the adjacent side. Okay, adjacent to what? To theta. Okay, then but this side here we have, it's called the opposite. So you can see that it's positioned on the opposite side of the theta, and this one here is adjacent to the angle here. Now if we are to look at this angle now at alpha, what you will see that is that this side becomes the adjacent, this one becomes the adjacent. Okay, so can you just have that adjacent, now adjacent to what? To alpha. Okay, and now this one now becomes the opposite. Okay, the opposite to alpha. Okay, so you must always check which angle are you positioned with, what is it with, and now we must also know that your adjacent opposite changes in respective with the angle that you're looking at. Okay, so now, how are these sides related? That should be our question. So here, if we are to look, let's look at respective to this alpha. So we have at this theta, sorry. So what we'll be talking about now is that how are they related? Let's call this H. And this one, what is it? The adjacent. And this one, what we call the opposite. Okay. Now, if we look at these, what we call these three sides, we find that how are they related in terms of length? You see that it's when you say hypotenuse squared is equals to adjacent squared plus opposite squared. And if you are to leave hypotenuse on its own, you find that you say that will be root of adjacent squared plus opposite what called squared. That's how you remove the exponent there. But now let's also see if you're looking at the one of the small sides, because these two are small sides, so we can just call them what called S1 and actually S2. So whenever you're looking at these sides here, whether you're looking for adjacent squared will be equals to hypotenuse squared minus opposite squared. So you always have to subtract the other side from the hypotenuse. That's how it works here. Okay, so in this case, adjacent is going to be equals to root of H squared minus O squared. Then here, if we are to look if we are to look for the opposite side, what we'll have there is that opposite squared is also equals to hypotenuse squared minus adjacent squared. And if you are to look for the opposite there, now you have H squared minus A squared. Okay, that's how you deal with with these values. Let's say here we are given, let's say we're given we're given maybe 13 here, and maybe this side here is let's just put 17. How now do we get this side here? This side is our longest side, so it's actually our hypotenuse. Okay, now if it's a hypotenuse, how do you get the hypotenuse? We say that hypotenuse squared is equals to adjacent squared plus opposite squared. Now, if we are to look with respect to this angle here, what will happen now is that we'll say what is it? We'll say hypotenuse squared is going to be equals to adjacent side, which will be 17 squared plus what is it? 13 squared. And in this case now, you will have h is going to be equals to root of 17 squared plus 18 squared. Then what do we get? Let's punch in our calculator and see. So we've got root of 17 squared plus 18, what called squared. We get root 48. So root 458. Okay, root 458. Then if we have root 458, how do you put it in decimal? It's going to be 21,4. 21,4 units. Okay, that's how you get what you call this. So you must know, you must remember how are these sides related. No matter how your triangle is what you call is actually what you call put there, you must know that whenever you look at the triangle, the right angle triangle, the line opposite, the side opposite to the right angle triangle is the longest side. Okay, now let's look what you call on our next page and see what we can get today. Now, we are looking for the longest side here, and we are looking for L. So in this case, we're going to say, okay, how do we get L? L is going to be equals to, let me use another color here that is more visible. So L squared is going to be equals to, what is it? It's going to be equals to 8 squared plus 7 squared, which is going to be L is going to be equals to root of 8 squared plus 7 squared. So you can see that when we are looking for the longest side, we do add. When you're looking for the small side, we subtract. So let's look here what we have. Let's get to see that. So root of 8 squared plus 7 squared, we get root 113. So it's root 113, which is equals to, let's put it in decimal, it's going to be 10,63 units. Okay, so that's what will be our answer. Now let's look at this one here, the smaller side. We're looking for the smaller side, and you can see that the longest side is given. So what do we know? We subtract the smaller side from the longest side. Simple like that. So here let's look for the S1. S1 squared is going to be equals to 15 squared plus, sorry, there, minus 12 squared, which is going to be equals to root of 15 squared minus 12 squared. Okay, then when you root that, what do we get? Let's see here, 15 squared minus 12 squared, we're going to get what is it? 9. So you can see what we are getting there is exactly 9 what you call units. Okay, then let's look at this one here, side 2. So side 2 again squared. We know that we're going to subtract the smaller side from the longest side, because once you see this right angle triangle, the opposite side is the longest. Okay, so here is going to be 25 squared minus 11 squared. Okay, then that will become what is it? S2 is going to be equals to root of that 25 squared minus 11 squared. Then what do we get there? Let's look at that and see. 25 squared minus 11 squared, we get 6 root 14, 6 root 14, which is going to be equals to, in decimal, is going to be 22,45. 22,45 units. So the answer, always remember, the answer you give, the answer is required in that particular quantity that you're dealing with. Okay, so if they want in decimal, let's say 2 decimal places or 1 decimal places, you leave it like that. If you just need to leave it in set form, you just leave it with the root. Okay, so this is the set form, and this one is a decimal. Now, so let me just indicate that as well. So here is said, here also is set. So if you leave your answer in set form, that's how you should leave it. And this one here, if they say 2 decimal places, you must know that you are leaving it like that. Now, let's move on to the next slide. Now, let's also talk of, now I think we are being introduced to cos to sin, which sin, and also what call to tan. Now, how are these what call also related here? So let's look at that. Now we're saying if we are to look at theta, according to the theta here, we are saying this will be the opposite and this will be the adjacent. Okay. Then if we are to look for the alpha there, for the alpha, let me just use another color there. Okay. So for the alpha, this will be the adjacent, this will be the opposite. Okay. So if you are to look for what is it for cos theta, so hypotenuse remains that. So if you are to look for the cos theta, which is this one here, cos theta is going to be adjacent over hypotenuse. Okay, so cos theta is equals to what is it? Adjacent over, so let's put this one here, the right color, adjacent over the hypotenuse. Okay, that's what we have there. What about sine theta? Let's look at sine theta. Sine theta is equals to what we call opposite. So we are looking at opposite there, and we're going to say it's opposite over hypotenuse. Okay, then if you had to look for the tan theta, if you look for the tan theta there is going to be equals to, what is it? It's going to be equals to tan theta is going to be equals opposite over adjacent. Opposite. So it's opposite. Where is the opposite there? Let me see there. It's opposite over adjacent. Okay, that's what we have here. So what can you use actually to remember this? What can you use to remember this? Let's see what you can use to remember this. You can use what we call Chasho tau. Now, what does Chasho tau means here? It means that when you look at this, you see that we are saying this C is cos. Okay, so cos means that adjacent over hypotenuse. Okay, and sine means opposite, what we call over hypotenuse, and tan means opposite over adjacent. So in this case here, you know that you are starting with the O over A, and here is O over H, and this one here is A over what you call H. Okay, so that's what you look at here and find out. So always remember this Chasho tau. You practice with this Chasho tau and you won't have a problem. Okay, now let's also see here, if you are to look at respect to what call with respect to our alpha, let's see what we'll get there. If we are to look at it with respect to alpha, let's say cos alpha is now equals to, we are looking at the opposite over what is it? Cos, sorry about that. Cos, we're looking at the adjacent over what you call the hypotenuse. Okay, so we are looking at this adjacent here is now this side here over the hypotenuse. What about if we are looking for the what you call sin alpha? What we'll look at now is that it's going to be the opposite, what you call over hypotenuse. It's going to be opposite over hypotenuse. What about if you're looking at for tan? Tan alpha is going to be equals to opposite, which is this opposite here, over what you call adjacent. Okay, now that's what you should remember here. So always remember this, that the side will change. So you look at the angle, you see, oh, that's the opposite side. You look at the angle, you see, oh, now that's the opposite side. So this one here adjacent to theta, this one adjacent what you call to alpha. Okay, now let's say you're given values here. Let's say you're given values here. You are given maybe let's say it's 15 there. what is it? Let's see if we did calculate before here. 15, 12, and 9. Okay, so 15, what called 12 and 9. Now, with this, you can actually simply get what we want here. If we want to look at this and say this is our theta, we'll now say cos theta is equals to adjacent, which is adjacent, over what call hypotenuse, which is going to be equals to 12 over what call 15. Okay, so it's going to be 12 over 15. So we leave it like that because we're looking for cos theta, and it's actually 12 what is it, over 15. Now, what about if we're looking for sine theta? Here it's going to be opposite over hypotenuse, which is going to be equals to 9 over 15. And if we are to solve that, I think we can still simplify here. So 3 goes into both here. It goes there 4 times, and it goes there what call 5 times. And here we go what call with the 3 also. 3 goes also here 3 times, and what call into 15 5 times. Okay, now let's look at what is it? Tan. Now tan theta here will be equals to opposite over adjacent. In this case here, we are looking at 9 over what called 12. And with this 9 over 12, we can still have a common factor there, which is 3. 3 goes into 9 3 times, and 3 goes into 12 what called 4 times. So that's what we will have there as our values. Okay, now let's look at maybe something just to put what called to quickly apply what we're talking about here. State the following in terms of G, K, and M. So sine K. So sine K, we are looking at this side here. Okay, so sine K. Okay, we're gonna use blue there. So let's say with sine K is gonna be because the side that is opposite. Remember, sine K is opposite over hypotenuse, which in this case here our opposite is K, and our hypotenuse is M. So that will be our answer there. What about tan K? Tan K, we are saying it's opposite over adjacent, and this opposite it's our K, and our adjacent is G. Okay, what if we are looking for sine G? Okay, I'm just picking randomly here. I want you to finish the rest. Sine G, now we're looking at the G, and we are saying, okay, if it's sine G, our opposite now have changed. It's now G. It's going to be G. So let me just opposite over hypotenuse, which is going to be G over M. Okay, what about if we are to look for cos? G. Cos G is equals to adjacent over hypotenuse. In this case, our adjacent there is K over M. Are we together? So it's K over M. So you can actually see that sine K and sine cos G are the same. But we don't need to worry about that at the moment. Okay. What about if we are looking for tan G? Tan G will be equals to what we call opposite of adjacent, and the opposite there to G is G over adjacent, which is actually K. So you can see what we are getting there. Let's get to see what else do we have there. We have got this question here with us, and what are we being asked to find here? Determine the value of what we call sin n. So we're looking for this angle here. When you're saying sin n here is this angle here, and when you're looking for this angle, we need the opposite side. So we need to calculate the opposite side first. So what do we know? Or if we are to look for the opposite side, let's just take this question 1 and this one what we call question 2. Now with question 1, let's try to find BE. So what do we know? BE is a smaller side, and this one is a longer side. So we'll say BE squared is equals to what we call BN squared minus what we call EN squared. And here, what do we know? We know that B E is going to be equals to let's put in the values now. It's going to be equals to 17 squared minus 15 squared, which in this case, BE is going to be equals to root of 17 squared minus 15 squared. Let's see what we get there. Root of 17 squared minus 15 squared, we get 8. So we are getting 8, in this case is centimeters, okay? So it's centimeters. So we can put in the value there, 8 centimeters. Now, what is our sine n? Our sine n now, we'll say now sine n is going to be equals to opposite over hypotenuse. And what is our opposite there? Our opposite is going to be n, then hypotenuse it's what called 17. That becomes our final answer like that. Okay, let's look at what called the question 2 there. Now, on the question 2 here, we are asked to find tan C. And to find tan C, we need opposite. We need this opposite here. So we need this opposite here. So to find the opposite side, what do we know? We are going to say that's our PO and OP. Okay, OP squared is going to be equals to our hypotenuse, which is we can start with OC squared minus CP squared. Now let's put the values in. OP squared is going to be equals to 5 squared minus 4 squared, and OP here is going to be equals to root of that, which is 5 squared minus 4 squared. Okay, so can you see something here? Whenever you put the root this side, you must remove the square there. Okay, because if you put the square there, then it won't work. But you are putting when you root this side, you're removing the square. So you must always know that when you root this, when you put your root that side, we mustn't see anything here. Now, then let's see here, 20 is going to be 25 minus 16, you get root 9, and root 9 there is actually 3. So now we have got 3 units here. So this one is 3, K centimeters. Okay, now how do we get tan now? Know that tan C is going to be equals to opposite over adjacent. And what is our opposite? Our opposite to C is 3. What about our adjacent? Our adjacent is 4. So that becomes our value there. That becomes our answer. Okay, so until next time, guys, thank you so much.